Question is an array which is given to us which have following elements 82, 101, 90, 11, 111, 75, 33, 131, 44 and 95, 93 is hippified. Which one of the following options represents the first three elements in the hippified array? So if you can see, we need to build a heap tree first. So based on the order, we need to start from the initial indexing. So it is the 0th index. So I will put this particular element at the root node, that is 82. Thereafter the next element 101 will be there. So 101, and thereafter 90 is there. So I will put 90 on the right side. So in the same manner, I am going to follow left to right approach, left to right, and top to down approach, and top to down approach, right? Because we need to make a heap tree. So I am going to follow left to right, left to right, left to right, and top to down, right? In this fashion we are going to make a tree first. So similarly the next one is 11. So 11 will be here. Thereafter the next element is 111. It will be placed on the right side of 101. Thereafter the next element is 75, which will be on the left side of the 90. The next element is 33, which will be on the right side of the 90. Thereafter the next element is 131, which will be on the left side of the 11. Thereafter 44, which will be on the right side of the 11. And thereafter we are having 93, which will be on the left side of 111, that is 93 here, right? Now after this, this is just a heap tree, but we need to heapify it. We need to perform heapification here. So now I am going to perform heapification. So while performing heapification, I need to keep one thing is in my mind, that whenever I perform heapification, then heapification basically performed from bottom up constructions, where it is a bottom up construction method. It is a bottom up construction method. So if you can see how many elements we are having, 1 2 3 4 5 6 7 8 9 10. So in our complete binary tree we are having 10 elements. So I will just compare here 131 with 11, but 11 is lesser then 131. So we need to replace this 11 with 131, and 11 will be here. So ultimately what I need to do, every time I need to just compare the sibling elements. I need to compare sibling nodes, and after comparing sibling nodes, whoever is maximum, I will compare it with its root node. And if the root node is minimum, replace it with the maximum node. So here, out of 131 and 44, 131 was the maximum, so I have replaced it with the root node because the root node is having lesser value. After this I will compare 131 with 111. Again 131 is the maximum, so I will replace this 101 with 131, and here 101 will be there. Similarly I will also do on the right side part. Here 95, 75 and 33. 75 is bigger already, 75 is already lesser than 90, no need to manipulate. Again 131 and 82 will be compared. So 131 is the greatest one, it will come here, and 82 will be here. But it is not up to that. Why? Because I again need to verify that this 82 is whether greater than 101 and 111 or not, but it is not so. So out of 101 and 111, which one is greater? 111 is greater. So I need to replace this 111 with 82, and 82 will be here, and 82 will be here. Now 82 is again lesser than 93, which is not possible. So again one more performance, one more swapping will be there. This 82 will be replaced, then 93 will be here. So after this, if you will see, my tree will look like this, which I am constructing. My tree will look like this after heapification. After heapification, my tree will look like this. The tree will look like this. The root node element is 131. Thereafter, on the left side, I am having 111. On the right side, I am having 90. On the left side of 111, I am having 101. On the right side of 111, I am having 93. On the left side of 90, it was 75, and right side 33, no change here. On the left side of 101, it is 11. On the right side of 101, it is 44, and on the left side of 93, it is 82. So as you can see that just I have placed this replaced element accurately on their place, and after heapification my tree is look like this. So what I need to do, I need to answer the question as per the requirement. The question is, which one of the following options represent the first three elements in the heapified array? So in the heapified array, again follow the same, start from the root node, go to the left, thereafter go to the right, and follow the same order. So we require first three element. First three element means 0th index element will be 131, first index element will be 111, second index element will be 90, and so on. Third index element, fourth index element, fifth index element, sixth index element, seventh, eighth, and ninth. So if you can see, I require first three elements from this heapified array, and that are 131 comma 111 comma 90, as you can clearly see in this particular heapified tree, right? So if you will check the option, then option D here in this part, option D, that is 131 and 111 and 90, right? It is the correct answer. Option D is the correct answer. I hope it is clearly understandable by everyone. It is clearly understandable by everyone. So the following question, it was asked in GATE 2024, right? And the topic is recurrence relation. The topic is recurrence relation, right? And basically, this belongs to the portion of algorithm where we can see the question. Consider the following recurrence relation: Tn equal to under root of n and then t square root of n plus n for n greater than or equal to 1, and the base condition is given n equal to 1 1. It is the base condition given into the recurrence relation. Which one of the following option is correct? So if you can see here, four options are given and we need to figure out which one is correct. For that we need to solve, we need to make characteristic equation, and thereafter we need to solve. So let's see step by step solution for this. So I am starting. The recurrence relation that we are having is Tn equal to under root of n, and thereafter t of square root of n plus n, where n is greater than or equal to 1. And if n is equal to 1, we can stop here, right? So if it is the case, in that case, we can stop there at base condition. Whenever base condition will be there, we will stop it. Right now, I can also write the same equation as n ki power 1 by 2 into t of n ki power 1 by 2 plus n, and I can give this particular equation, that is equation number 1, because I may need this equation later on for generalization purpose, right? After that, t n ki power 2, again and again in the recurrence relation, it is the basic concept of recurrence. It is basic concept of recurrence means a function calling itself. So now I am going to replace this n with under root n, that is I am going to put n ki power 1 by 2 again on the equation 1. So my equation now will look like n ki power 1 by 4 into t of n ki power 1 by 4 plus n ki power 1 by 2. How this equation came? This equation 2 came from 1, I have just substituted n की power 1 by 2 on the n wherever n is a function. So whenever there is a n, I am going to replace it with n by 2, right? And why I am doing it? For generalization purpose. Now this is my equation number 2. Now what I need to do? Now again I will substitute equation 2 in equation 1. So if I will do this, if I will again substitute equation number 2 in equation number 1, I will get the following equation, that is Tn equal to n ki power 1 by 2, and thereafter n ki power 1 by 4 into T of n ki power 1 by 4 plus n की power 1 by 2 and closing bracket plus n. And I can say that if I am going to solve it, it would be like n की power 3 by 4 into T of n की power 1 by 4 plus 2 of n plus 2 of n, and it is equation number 3. So this equation number 3 we just got when I am going to substitute the equation number 2 as it is on equation number 1. So all the n will be replaced by equation 2. Now in equation 3 I am getting the result like this. This is equation number 3, right? Now if you will see here, again if I am going to continue it, if again I am going to continue it, I can write it like n की power 1 minus 1 by 2 ka square, because this result will generate ultimately n की power 3 by 4. And for easiness I am doing this, n in की power 1 minus 1 by 2 square into t n की power 1 by 2 की power k plus k into n, right? So what we have did, we have just put, we have just replaced this 2 with k. Now here I can just replace it, or I can just write it as n divided by n की power 1 by 2 की power k in just for in the power form of variable n. And I can write n equal to t into n 1 by 2 की power k plus k into n, right? Now if you can just see here, this is the particular equation that we got, and this is the variable which is constant, and this constant variable will be replaced by, this particular constant will be replaced by the base condition. This particular constant will be replaced by base condition, right? So the base condition is 1. So I need to solve this equation first. N equal to n की power 1 by 2 की power k. So I can write it like n equal to n into 1 by 2 की power k. And if I am going to take logarithm on both the side, if I am going to take the log, then it will become log of log n. Ultimately what it will become, log of log n. The k will become log of log n. So at the end I will get the solution in the form of theta of n will remain as it is, t of n divided by 1 by 2, it is become 1, it is a constant, and k will become log of log n. So the final answer is theta of n into log of log n, right? So if you will see the options, then option A is the correct answer for this recurrence relation, right? So this was the question from algorithm part, and this is just the solution. And this question is asked in 2 marks. This question was asked in 2 marks from algorithm. The topic was recurrence relation, right? Okay. Was asked in GATE 2024 computer science, 2 marks. The subject is algorithm and the topic is heapification. The topic is heapification, or you can put it under the broad category of divide and conquer. And under divide and conquer we can go to the sorting technique, and under sorting technique we can see the concept of heap trees, and under heap trees we are having a topic heapification, right? So from there it was asked in 2 marks. The question is like, consider a binary mean heap containing 105 distinct elements. Let K be the index in the underlying array of the maximum element stored in the heap. The number of possible values of K is. So if you can see here, as per the question, we are having 105 distinct key, 105 distinct keys, right? Distinct elements, or you can say like that. Now mean heap is given, mean heap is given, and there are k indexes. There are how many indexes? K indexes, which is given in the question itself, right? So based on that, what they are asking, the number of possible value of k. So there is a direct formula that number of leaps are nothing but the seal value of different elements or keys, right, and divide it by 2. So the total number we are having here is 105 divide by 2 and take the floor value. So I will get 52.5. So it will give me the upper value, that is 53. Direct formula. So 53 53 is the correct answer of this question. 53 is the correct answer of this question. I hope it is clear. This question asked from algorithm. The topic is trees and asked for 2 marks. The nature is MCQ. Let G be a directed graph and T a DFS, that is depth first search, spanning tree in G that is rooted at a vertex V. Suppose T is also a breadth first search BFS tree in G rooted at V. Which of the following statements are true for every such graph G in tree? So here are true. It means that multiple options can also be correct. So we need to go carefully with this, right? And we need to scan each and every option carefully. So option A is there are no back edges in G with respect to the tree T. Or option B, there are no cross edges in G with respect to the tree T. Or there are no forward edges in G with respect to the tree T. Or the only edges in G are the edges in T. So I need to first make a graph which will satisfy the question. So let's say if I am considering a graph like this, A, we are having a directed edge of A from B, and B is having directed edge C. Now if C is having a kind of a back edge to A, and further one more node is here D, let's say, and A is representing or having directed edge towards D, and D node is directed node towards C. So this particular question where G is a directed graph T and DFS spanning tree in G that is rooted at V at vertex V. Suppose T is a BFS tree in G rooted at V. So this condition is followed in this. Now if I will try to analyze here, if I am going to try the analyze the problem here, then what it is saying that there are no back edges. There are no back edges in G with respect to T. But there can be a back edge like this. There can be a back edge. In this situation, there can be a back edge possible, right? So we can say that no back edge is tree. So it is false. It is false, right? Thereafter, they are asking there are no cross edge. There are no cross edge possible with respect to the tree T. But yes, if you can see here, this particular edge is a cross edges. These are called as cross edges. So these are also possible. This is also possible. So here no cross is written. That is why it is also going to be considered as a false. Now option C, there are no forward edges. There are no forward edges in G with respect to tree T. So obviously we are not seeing any kind of the forward edges here. So as of now, we can make this statement as a true. And option D, the only edges in G are the edges in T. The only edges in G are the edges in T. But it is not so. It is not so because tree will have tree will not have exactly all the edges, because if I am going to go with the tree, then my tree will directly go from A to B and B to C, and I can cover D like that. So there is no cross edges here and there is no back edge. Thus option D is also false. So as per this question, which was asked in 2 marks, here option C is the correct answer. Option C is the correct answer for this problem. I hope it is clear. Following question was asked in GATE 2024, and the question is the number. Okay, the question was asked from the concept of DFS traversal of a graph, that is from graph data structure, and the nature of question is NAT. The nature of the question is NAT, and it was asked in 2 marks, right? And basically it was asked from depth first search traversal of graph. So if you can see the question, the number of edges present in the forest generated by a DFS traversal of an undirected graph G with 100 vertices is 40, right? The number of connected component in G is how much? So again, it is very easiest question asked by GATE, very easiest question, because there is a direct formula that I can write. The number of connected components, the number of connected components is nothing but n minus k, right? Where we are having n, that is total number of vertices, that is 100. And if you can see that the graph with 100 vertices, so this particular, this undirected graph, right, the number of edges which is present in this forest, the value of k is also given, that is 40. So if I am going to subtract it, I am going to get 60. So at the end, what I can say, that the number of connected components in this particular DFS traversed of undirected graph is 60. So the correct answer is 60. Just formula based question. I hope it is clear. You only need to know this formula and nothing else. Following question belongs to recurrence relation and asked in 2 marks from algorithm, and the topic is recurrence relation. The question is, the recurrence relation is given t0 equal to 1, t1 equal to 2, and tn equal to 5, tn minus 1 minus 6, tn minus 1 for n greater than or equal to 2, right? Which one of the following statement is true? So the process is, we need to calculate the characteristic equation, and thereafter we need to put the roots into the complementary value, right? So here if you can see, the equation look like this: tn equal to 5tn minus 1 minus 6tn minus 2 for n greater than equal to 2. Now if I am going to replace tn equal to r ki power n into the recurrence relation, then my recurrence relation equation will become Rn equal to 5 into Rn minus 1 minus 6 into r ki power n minus 2. So I need to make this further equation easy in order to get the root. So I am further dividing this particular equation from right and left, both sides, from r ki power n by 2. By doing this, what I am going to get, r square equal to 5r minus 6. So at the end, the equation r square minus 5r plus 6 equal to 0, and this equation is my characteristic equation. This equation is my characteristic equation. Now we can use the simple quadratic equation formula, minus b plus minus b minus minus b square plus minus b minus 4ac divided by 2a. So we will get two roots here. The value of r will be 2 and 3, or if you can simply see this equation, we can build up like r minus 2 into r minus 3. We can simply break this equation like this for getting the roots. So at the end, one root is 2 and r equal to 3, other root is 3, right? So what I need to do after getting the roots, that is 2 and 3, I need to go to the equation, that is a complementary equation of original, that is c1 into 2 की power n, because one root is 2, plus c2 into this 3 की power n, right? Now what I need to do, we are having two base condition, basically two base conditions are there, so we need to be very careful that which we will have to choose. So one base condition is t0 equal to 1 and other base condition is t1 equal to 2. Generally in question, if one base condition is given, then directly we can compare it with that, but here two base conditions are there, at 0 also, at 1 also. So in this particular problem, we need to evaluate the c1 plus c2 equal to 1, and here also 2c1 plus 3c2 equal to 2, because two base conditions are there, right? So if two base conditions are there, I am going to make it like that. And at the end, if we are having two variables and if we are having two values that we need to find, I can just multiply the first equation with 2. So I will get 2 equal to 2c1 plus 2c2, and this equation is remain as it is, that is 2c1 plus 3c2. And I will just subtract, so, from equation 2 to equation 1, subtracting 2 minus 1. What I am doing, 2 minus 1, equation 2 minus equation 1. So I will get the value of c2 equal to 0, because 2 minus 2 will be 0. And if I will put this c2 equal to 0 in any of the equation, I will get c1 equal to 1. So I just need to replace this c1 and c2 value in my complementary equation. So if you can see, it will look like that, tn equal to 1 into 2 की power n plus 0 into 3 की power n. So at the end we got the 2 की power n, right? So the answer will be theta of 2 की power n. So if you will match the question, option is A, tn equal to theta 2 की power n. This question was asked from algorithm recurrence relation from for 2 marks, right? Option A is the correct answer. First characteristic equation, which was this, thereafter roots, which was this, and thereafter simply complementary equation, because we have replaced here tn with rn, so that, and thereafter getting the constant value and putting the substitute value of this constant again into the complementary equation, and at the end final time complexity of the recurrence relation, which is theta of 2 की power n. So option A is the correct answer of this gate problem. I hope it is clear to everyone. This question is asked from the arrays and it is 1 mark question. Question is, let A be an array containing integer values. The distance of A is defined as the minimum number of elements in A that must be replaced with another integer so that the resulting array is sorted in non-descending order. The distance of arrays 2, 5, 3, 1, 4, 2, 6 is. So it is 1 mark question asked in NAT format, that is numerical answer type question, and very easy, right? If you can just see, we just need to sort this array in non-decreasing order. In non-decreasing order, we need to sort this. So after this, I am going to get 1, 2, 2, 3, 4, 5, 6. This is after sorting the array. This is after sorting the array A, which is given in non-decreasing order, right? Now original array is already here, so I am going to compare it with, and this is my sorted array. So we need to calculate the differences. Now what we need to calculate, we need to calculate the differences. So here three differences are there basically. Let's say my indexes are, I am representing the indexes with 0 onward. So 0, 1, 2, 3, 4, 5 and 6. So here I need to replace a0 with 1. I need to replace a0 with 1. So this is one of the difference. And after that I need to replace a2. I need to replace a2 with 2. A2 with 2, right? This is the second difference. And thereafter, after that I need to replace a5. I 3 4, okay, in the same fashion it is here. So a5 I need to replace it with 5, and after that all are on the correct position. So there are three differences. So distance between the array will be 3, because we need to work in non-decreasing order fashion. So once the element replace, it is already going to make distance for the other elements. We do not need to make the separate space for that. By default automatically it will be generated, right? So the correct answer for this question is 3, because there are three differences between them. I hope this question is clear. Was asked from algorithm, and the question was asked for 2 marks, and the nature is numerical answer type. The topic was chromatic number, that is from graph theory of algorithm. The chromatic number of a graph is the minimum number of colors used to proper coloring of a graph. The chromatic number of the following graph is what? So you can choose any graph or you can choose any color. Let's say I'm choosing color 1 here and color 2 here. So if I am choosing color 1 here, I cannot choose color 1, but I cannot choose color 1. I can choose color 1 here. I cannot choose color 1 here. I can choose color 1 here. I cannot choose color 1 here, but I can choose color 1 here, right? Now here color 1 not possible, not possible, here not possible, and here not possible, because they are adjacent edges. So I need to choose separate color for their adjacent. So color 2. So color 2 can I choose here? Yes, because it is not adjacent with C2 anymore. Can I choose color 2 here? Yes, it is not adjacent with that. And can I choose color 2 here? Yes. So ultimately, if you can see, the chromatic number of the graph is 2, because 2 minimum colors we are required for coloring this particular graph. So 2 is the correct answer of this question. I hope it is clear